Welcome to Google Cloud's Global Digital Conference, The Future of Your Data Warehouse. My name is Felipe Hoffa, and today we will be talking about 10 pro tricks for BigQuery Superpower. At any time during our live session, you can ask questions on our platform and Googlers are standing by to answer them. Let's get started. Pam, pam, pam. So, I have this whole blog post ready for you. If you want to follow along, you can run the same queries that I'm running, and we are going to be reviewing the top 10 tricks to make you a BigQuery superhero. And you might not know that if you know SQL, you are already a hero. You have the power to answer questions that other people have. You can save the day when someone from the business department comes asking for the latest numbers they need to fill in their business report. You have answers for them. And on your free time, you can be looking out for insights that no one has ever seen, and you can synthesize data, you can find results. And if you have been using BigQuery, you are not only a hero, you are a superhero. You can run queries faster than anyone else. You can go around and you don't need to think about indexes. Like where we are going, we don't need indexes. You can run this whole full table scans. You never have downtime. There is no vacuum procedures. You can just run your queries. So let's review the first superpower, the power of data. Let's say your favorite person has been trapped by an evil entity and they won't release them until you answer one riddle. So they have this question for you, and you have 10 minutes to answer it. And the question this time will be like, who were the top 10 superheroes on the English Wikipedia during the first week of February 2018? And you're like, oh, how can I even answer that? Like, how can I get the pages for Wikipedia? How do I know who are the superheroes there? How can I find who were the top superheroes during this specific week? And I only have 10 minutes to answer this question? Oh no. But turns out it would take way less than 10 minutes to answer this if you have BigQuery and you have the data. Let me show you how. Here in the power of data, I have my first query, and you can just take this query. You can copy paste it into BigQuery. This is our BigQuery web UI. Let's run it and let's see how long it takes to take all of the page views for Wikipedia for 2018, join it with Wikidata, which is our knowledge base in this case, and take the page views between these two dates. And these are the results. These were the top superheroes during the first week of February 2018. Black Panther, Black Lightning, Cable, Batman, Spider-Man. We got this answer in less than 10 seconds, 6.4 seconds to be precise. And we might be able to free our friend now, but then the riddle master is asking us more questions. He wants to know more about these superheroes. Okay, let's write an even more complicated query. I have it here. You can click here. You can get my full query that goes through Wikidata and extracts more facts about these superheroes. Let me run it here. And now this query will take a longer time to run. I'm doing more joins to extract facts, convert these facts from IDs into text. And after some seconds, give me a minute here, we will get our result. How much more can we know about these superheroes that were so popular in this week? Also, feel free to modify these queries. If you want to know, instead of heroes, you want to know politicians or computer data scientists or wherever, you can go and find out wherever you want to know. So yeah, what do we know about Black Panther? He's a superhero, a mutant. He's part of the Fantastic Four, of the Avengers, and he's part of the Marvel universe. And Black Lightning is from the DC universe. And even in 2018, Carol Danvers was already famous. She's also an aircraft pilot, a journalist, an editor-in-chief from the X-Men and the New Avengers, and part of the Marvel universe. And we can tell so much just with some simple SQL queries. Copy-paste them, run them, and unleash the power of data. There's so much that we can do. Let's go now to the superpower number 2, the power of teleportation. What do I mean by this? Let's go back to our query. You can see that I did a join between Wikidata with the page views from Wikipedia here, and let's say you want to know more about these tables. Turns out the BigQuery UI has a lot of shortcuts. Some of you may have not discovered it, but if you click here, you will find the shortcuts that we have available, and they're really cool. For example, if I'm writing a query, I can go and just start doing some autocomplete, or I can look for my top functions. Like, I don't remember my functions, it doesn't matter, I can autocomplete. Let me delete this from here because we're not going to use it now. And let's say we want to go instantly to any of the tables I'm querying. Just press Command. You can see that the tables are highlighted now. You can click on it, and suddenly here I am on the latest edition of Wikidata that I have made available here. So you can see that this table from Wikidata has 800 gigabytes of facts of more than 46 million entities. Or if I go to see my page views table from 2018, this table has more than 2 terabytes of data. That's a huge table. It has 55 billion rows. And you can see that with this join between facts, subclasses, we express how much each superhero did, and it only took us 20 seconds or even less. Let's go back to our tables. Now we have the superpower of just moving around and using the UI, just make the most out of the web UI. Another really cool trick here is if you're looking at the schema of your table, instead of typing the name of the columns, you can just start clicking on them and they will show up on your query. I really love being able to do this. What's the next superpower I want to show you today? The power of miniaturization. And what do I mean by this? These are some huge tables. Like my page views table has 2 terabytes of data, and then I have like 1 terabyte of facts, 600 gigabytes of facts from Wikidata, and we were able to run this query within our free quota. Like, remember, everyone every month has a free terabyte of queries. So that's really cool. But if you go out and scan 2 terabytes of data, that will get rid of your free quota really, really quickly. So what did I do here? Let me go back to the blog post so you can see where to go to learn more about this. My first query took 4.5 seconds. It processed 10 gigabytes of data. That's way less than the 2 terabytes each of the biggest table has. How did I make that possible? Let me copy paste the query again, the simple one. I have it here. I will run it in this other window, and again, it should take us only a few seconds to run it. And you can see that the prediction was that this query was going to use 45 gigabytes of data, but it ended up using only 10 gigabytes. That's really cool. That's because my page views table that I have here, I clustered it. So you can see in the definition here that this table has been partitioned by day. So instead of scanning the whole 2 terabytes for 2018, I'm only scanning the first week. But also this table, when I installed it, I clustered it by the wiki and the title. That means if I'm filtering for the English Wikipedia and I'm filtering for only certain titles, then I only query a small fraction of the data instead of just scanning everything. Another trick that I didn't teach you in the part of teleportation is that you can even run queries over subqueries. So for example, if we wanted to see all of the superheroes on Wikidata, I can go mark my query and I can run with Command E just the stop query. So for example, if from Wikidata you only want to see all of the superheroes we have there we have them. The Huntress, Stephanie Brown, Adam Warlock, Juniper, and I was able to run this subquery. And then let me delete that subquery. And so I'm not going to be doing a join anymore. I just want to see how many page views did one superhero get from Wikipedia during this week. So I will add, for example, that the title is Carol Danvers. How much will this data will go through? We have Carol Danvers here. She got 12,000 page views this week, and I only scanned 2.4 gigabytes. That's way less than the 2 terabytes of the table. So, and this is how we miniaturize our queries. Just make sure to cluster your tables. I wrote a whole blog post about it, so feel free to come to the blog, our main blog post, and find here the blog post of how to optimize your tables with clustering. The next power I want to talk about is the power of X-ray vision. And what do I mean by X-ray vision? These queries are running over a giant amount of data, and they are joining many tables, and sometimes they run super fast, and sometimes they run rather slow. And if you want to know what's happening behind the scenes, if you want to see what BigQuery is doing, you also have that power. You can see what BigQuery is doing inside. Let's go back to this query that took a long time to run. Query history. It was this one where I was joining all of my facts. Let me open it up. And when I open this query, you can see that it took 30 seconds to run. It processed 17 gigabytes of data. And I can click here on execution details. And you can see here that, yes, it took 30 seconds. It used 30 minutes of slot time. This is basically how many machines were working in parallel to run this query within those 30 seconds. It shuffled 12 gigabytes of data. And we have here an explanation of what happened and what were the slowest steps. This one is a little hard to read here. So if you want, one of my tricks is to just go back to the legacy BigQuery web UI that had a more compact view. Let's see if we can find the same query. Here it is. Let me open up the query, and we can also find the details here, and you can see the same list of steps. And we can see step by step how much data each one processed. And what's really, really interesting is that we can see which steps were the slowest one. So in this case, it was step 6 and step 06. And what was happening with it in each step, we can see that we are reading data out of the subclasses table. And somehow we are reading 56 million rows out of this table, and we are outputting also 56 million rows with 11 parallel inputs. It's taking a long time. And it turns out we have options. So what I'm going to do here, since this was our slowest step in this huge query, instead of reading this data out of the subclasses table, I'm going to read it out of the Wikidata table. So let me copy the name of the table out here. Let me copy it out, replace it here too. Those were the two slowest steps. Let me run the query. Let's see how much less than 30 seconds it takes now to get basically the same results. Well, it's running now. Let's give it a minute. What's really, really interesting here is that I thought that the query was going to run faster because the subclasses table is smaller. Well, the query is running faster when I do the join with the biggest facts table. Here we have it, same results. And if we look at the details up here and we look at all the steps, now we don't have the two most slowest steps. Now we have one that is a join. And it makes sense for this step to be slower because this is a mega join between our page views within Wikidata. And you can even see details like with our X-ray vision, we can see details like we were doing the whole join between starting with 3D man and ending on Zorel. That's basically the whole alphabet of superheroes between these dates, and it all worked magically. And now our query took half of the time to run. So I find that really cool. Use the power of X-ray vision, understand how your queries are running. And even then, if when you have super complicated queries, even this can be a little too complicated to read because you have a lot of steps in parallel. My teammate released a tool that allows you to look at all these explained plans in a way more graphical way. Find this blog post by Stefan Main here. I left it on my blog post. And my next power will be the power of materialization. What do I mean by this? Is how did I even find all of this data? How did I bring it into BigQuery? And by this, I mean using all the power we have to bring data from outside and make it available as tables in BigQuery in the easiest way possible. So I have a whole blog post about it. You can find it here. I just want to show you some little details of my tables. Where I have my Wikipedia here, a lot of this starts as raw data. So I materialize these tables here, but I'm taking out of Wikipedia CSV files, CSV files that have been zipped. I take those CSV files, I put them on Google Cloud Storage, and I read them raw into BigQuery. And I do all of the parsing inside BigQuery instead of just relying on the CSV parsing because those rows are a little more complicated. The same with Wikidata. Wikidata publishes this huge dump of JSON data. And BigQuery has the power of understanding JSON and parsing it within SQL. But I need to do more complicated stuff. So let me show you my Wikidata raw. And instead of ingesting it as JSON and columns and doing all of that at ingestion time, I just ingest each row as an item. Each row is a plain CSV row that I can show you here. So let me scroll here. This is one row of Wikidata. That's a lot of JavaScript here, and parsing it takes a lot more than you can do in a simple SQL query, but I'm still able to do it all lazily, especially because I'm going to use my next superpower. What's my next superpower here is the power of the multiverse. And what do I mean by this? We live in a universe, in the SQL universe, where we have data and we have the power of analyzing it. Yes, every universe has its own rules and its own limitations. And SQL has some limitations too. It's not a full programming language. And how cool would it be if we could jump to a different universe? Like, for example, JavaScript. If we were able to do things in JavaScript and make everything work interconnectedly. Oh, we're in the SQL world. Let's jump to the JavaScript world, analyze our data there, and come back to SQL. Well, turns out we can. So back to my blog post here. This is navigating the multiverse. Before talking about JavaScript, I want to show you this really cool feature is that we have the ability now to define persistent UDFs. So you can come here, and let's say, for example, that you want to find the median of a collection of numbers. That's not really easy always with SQL, but now it is because I can just do a select.fhoffa, that's my name, .x.median of an array, 1, 2, 3, 4, whatever numbers I want to write here. What's the median of this list? You can see here that I'm able to find it and run it as a function. And I have made these functions public, so you can use them. And you can do wherever you want within SQL, create a function and let other people use it. If we jump to my FHOFF a project, you can find some of the functions I made available: leverage time distance, median, a cast to integer. And this one, parse number, is really, really interesting. So for example, I want to parse a number like 123. This is not something that you can easily do with SQL, but now you can do it with BigQuery. And there you have the result. How did I make that? Look at this parse number at the codes of this function. I'm just telling it that it's a JavaScript function. I can call JavaScript within SQL. And to write, I didn't write all of the logic to parse a number. You can just go here. I downloaded this library out of the internet, JS Compromise, that does natural language processing, and it will parse the number and return it, and now everyone can do this kind of tricks. And to parse, for example, the Wikidata data, I'm doing all of this in JavaScript. I take a row of JSON, I parse it within JavaScript, I define my columns, and then, and only then, I put the columns out. Check it out again on the blog post if you want to see more. What's my next superpower? The power of time travel. And this is a very scary demo. Let's say we have our peaceful universe, and someone evil wants to take our table. This is a table with 100,000 rows, and someone wants to delete from our table, and they're going to delete half of the rows randomly. Like, how would they do that? They can do a delete from my table here, and they are going to say where I will use my random int function. Let's get a number between 0, 1, and 10. And if the number is less than 5, that random number will be deleted. Okay, you can see what's happening here. We are deleting half of the rows randomly. We don't know what rows we are deleting, and this is bad. My peaceful universe table now has 55,000 rows. We need to move on. We need to survive with all of these rows. I heard one row say, "Oh no, Mr. Hoffa, I'm not feeling so well." But I need to come back to them. How can we even recover them? So 5 days later, let's say you want to look at your data again. So we do our select star from our table. And of course, we only have half of the rows there. Well, turns out we can do some time travel to solve our problem. And I left you the query here. Here it is. We can do a for system as time off. And we can, in this case, jump back 5 minutes. And if we do a select count star, just to see how many rows we had 5 minutes ago, yes, there are our 100,000 rows that are still there. We can recover them, and we can go back in time and bring them all back to our universe. How cool is that? Next power. Let's go really fast. The power of super speed. How can we do analysis way, way faster than anyone else? For example, I have a whole blog post about this, so I will go really fast. If you want to see the blog post, click here. But we have hyperlog which means we can do approximate results way faster than you can do normally. Just to think about it for a second, if you're counting uniques, you need a lot of memory. Let's say you have 1 million unique users and you want to count them from a table that has a lot more than 1 million rows. You need a lot of memory to see if you counted each one. You need to remember who you've seen already and who you have not seen. And that's a lot of processing power, especially if you want to do uniques by month, uniques by day. That takes a lot. That takes a lot of resources, but not if you use our approximate functions. So just take a look later of how you can do approx stop count, and take a look at how you can even have the intermediate stage, get sketches out of the approximate counting of uniques. Next power, before I run out of time, the power of invulnerability, which means how can we stay safe from our most common enemies. And one of the worst enemies for me is, you know who it is? This? Let me jump here to superpower number 10. What is this? A black hole. When we're doing queries, when we're calculating averages, that black hole is the division by 0. You want to get an average, you get all of your counts, you divide by the number of elements you have, and if you have 0 elements, that gives you an error. Just to write a very simple query, select 1 divided by 0. This can happen out of the data, and this is a division by 0. And in this case, we can solve it very easily, but if it's hidden between all of our rows, that will take a long time. Well, turns out we have save functions, save divide, for example, so we can divide 1 divided by 0, and instead of throwing out an error, it throws out a null. And there's a lot of other operations that can give you as errors, like cast, mathematical operations. Just using the save prefix before the function name will make sure that we don't get errors, but we get nulls instead. You can look at the documentation here. I left a link. You can see that we have a save divide, we have save cast, and also most functions you can add a save prefix. And what's our last superpower in these few seconds I have left? The power of self-control. You know, with great powers comes great responsibility. All superheroes struggle when they have to learn the superpowers for the first time. They break up stuff because they don't know how strong they are. Some never learn to control themselves. What I want you to remember is that you have the power to set up your cost controls. If you are on the free tier of BigQuery, if you have not put your credit card, there's no problem. There's no way you can run a bill. You will stop running your queries when you are out of your free terabyte. But if not, you better have your cost control set up. Once you put your credit card, remember to tell BigQuery that you don't want to spend more than a certain amount a day. We have the official documentation, and I left some screenshots here too of how to do it. So these are the 10 superpowers we reviewed today. We saw the power of data, the multiverse, teleportation, super speed, miniaturization, time travel, X-ray vision, invulnerability, materialization, and self-control. These are all things you can do with BigQuery. And there's a lot more, like for example, the power to predict the future. Check out Stock for that. And there's so much more. So make sure to also follow the superpower number 11, the power of community. No superhero should stand alone. Make sure to join us on Reddit, where we discuss all of the news, on Stack Overflow, when you can come to ask questions or help new people that are just learning their superpowers. You can follow me on Twitter. I'm Felipe Hoffa, and you can follow also all of my friends. I have a list here of friends, a list with all of my favorite BigQuery people. So, data heroes, let's leave this here for today. Thank you for tuning into the future of your data warehouse. Stay tuned for more content from Google Cloud thought leaders, experts, and customers. And be sure to visit Cloud on Air with google.com to find out more. I'll be back, and stay curious.